As for the Disco XBLE, as we all know, this is the latest version of Disco X series, and this hardware number is 1.3 and firmware number is 2.7. In 2022, about 2 years ago, I developed this boards based on Bittig and Oliver Lando's design. And with their help, I replaced all of the obsolete components of the original Disco X2 boards, and I rewrite all the related drivers. For the biggest change is I changed to the obsolete Bluetooth module used in Disco X2 and switched from SPP profile to Bluetooth low energy. And this is a big change because the BLE standard has a longer communication distance, transmit distance, and a lower power consumption. I adopt a module from a company RF Star. The module name is BB22A3, and based on this Bluetooth module, I defined a new communication protocol. And for the magnetic sensor and accelerator sensor, these two sensors are also obsolete in the old Disco X2 board. I changed to RM 3100 and LIS 2HH12. These two chipsets are all the alternative parts of the old parts used on Disco X2 boards. And since a lot of chips and Bluetooth modules were all changed, I worked with Topo Survey and Case Order to develop a new driver. And currently, this full application based on Android platform all supports the Disco XBLE boards. That's what I did in these 2 years. And this is the photo of the new board. And the board is still based on Leica X310OOE7400X as Disco X2, and the boards are under production again. But the problem is Leica's X310E7400X is obsolete. So the following, I will discuss some problems I met with Disco X problem. First, I have to draw the conclusion that Disco X series is focused end of life cycle for Leica's obsolete. I encountered a lot of problems in the 2 years. For example, the first problem is the cable. A lot of cables are aging and they got dissolved with users' assembly. This problem occurs especially frequently in Leica made before 2016. Because the older Leica's cable got aging more seriously. And problem 2 is the keys, especially the on keys. After a lot of cables too many times used, they make too many shots, and finally the on button got sticky, got short circuit. The on button cannot be charcoal anymore. This is the schematic of the Disco X2 boards. For example, in the A point, it should be always high level, and with the problem keypad, there is a way. There's a lot of poses here, and this is the finally cross the way on B point. There's another type of poses here. In fact, in the B poses, it should be always in low level. And finally, cross the power regulator TPS cannot be throttled completely, which further cause the battery to be drained. So I met a lot of disco X finally with a battery problem. Battery got drained after I made another this. It's the keypad problem. But what's worse is it's more and more difficult for me to buy replace parts. By even use the Leica X310 for repairing. That's the biggest problem I'm facing. And another problem is I think this device sometimes needs calibration, and it has no magnetic interference detection. Sometimes I put the disco X near another electronic devices or maybe a drill device or some little batteries together in my pocket, and the disco X sometimes lose calibration. But after lose calibration, there's no magnetic interference alert for users. I have to download the data to Cavway and to check if the magnitude and DIP is normal to check if the calibration still works. That's the problem of this X currently. So and another problem is I don't think because even though Leica's case has a brilliant design and a very good ergonomics, but it's not designed for Earth magnitude field measurements. For example, in the latest type laser, there's a big inductor. As we all know, inductor is magnetic, and this inductor is very close to the magnetic sensors. It has influence, it has an impact on the magnetic sensors. And the keys are also magnetic. If you put disco X, if this components or parts got magnetization, then the disco X lost calibration. I assume losing calibration has relationship with those magnetic parts. Even though here I need some further study, but it's not so good to put some magnetic parts so close to the magnetic sensor. This is written in the PNI datasheet of RM series, RM 3100 sensors. So I am looking on the next generation of disco X. The name I gave it is Cavway X1, and it will not rely on any third-party product. Will not based on Leica. And this is the new photo, the photo of the next case survey device I'm working on. Firstly, it will be small. At least I've just got case 3D printed, and it has almost the same size with this X2. And you can see the length, width, and height. This is the size without tail, and there will be a small tail here, approximately 2 centimeters tail. And so, because it's very small, it can be put in a pocket of a pixels. And the waterproof level is IP65. It's the same as the Disco X. I know this is not enough, so I will design an external waterproof case in the future, which can achieve the waterproof level IPX8. And in the new machine, it will adopt only LCD 128 plus multiple 128 dot pixels. And for the battery, it will adopt a much larger volume battery with 1,800 milliampere hours. Compared to Disco X2, only 600 milliampere hours. And the new battery can support 100 hours standby with level. Another functions, it currently adopts keys with 1 million times in euros, especially on key. So I guess there will not be any problem with on button about DP or got short circuit. And can be placed on a triple. There's a screw hole at the bottom of the case, and the removable tail, and it will 150 meters. And there's a USB-C port supporting history data download and firmware update. The firmware will keep update and keep be supported. Users will not worry about maybe some data loss. They can acquire it by user with a new Windows application running on it, which can communicate with device. And also the same adopt Bluetooth low energy standard. The final is the device will design and manufacture in China to reduce cost. This is the new main board of the new device. Two sets of sensors are adopted in backplate. Two sets of sensors can be the result from two sets of sensors can be compared to distinguish if there's some calibration loss or maybe some magnetic field interference. And all the components and case layout are optimized for magnetic field measurement. All the parts that have all the magnetic parts are placed as far as possible from the magnetic sensor. And a lot of parts are customized to achieve non-magnetic. For example, I just customized a batch of non-magnetic screws from the factory, and I just got a new batch of non-magnetic batteries from the factory. And other components such as USB ports and keys, and I will try to choose them with very weak magnetic. To achieve this goals, I have tried a lot of USB ports, a lot of keys to let their magnetic to be weak. And the power supply circuit is also redesigned to achieve better lithium battery protection. There will be no lithium battery drains in the future. I will prevent this situation to happen again. And the non-magnetic lithium battery volume is 1,008 milliampere hours and has a longer working time than this one, and this one. Since we are using not only LCD, it can allow me to develop a more user-friendly menu and user-friendly user interface. There will be a manual implemented. And the user interface and the way how users operate it will be as close as possible to Disco X1 to Disco X1, just to let users to get familiar with as soon as possible. And as the most inclination expands, gravity magnetic field strength, a DIP angle, as well as the sensor raw data will be shown during the manual. That's the same with the Disco X2's user interface. And the data table is also implemented to show history data. And users press the OK button. A detailed shot can be shown orderly. And there's some more obvious ways to notify users. For example, there's a bigger double beep, stands for that, and the LCD screen backlight will also flashes when a lag is detected. And there will be a device stable logic. If the users hold the device stable or there's a shake on the device, there will be a logic. And there will be also some data incurrency or magnetic interference alert. And the other new function is the standalone calibrations. The new device can implement a calibration without application smartphone. But the classic way to make calibration with a smartphone is also reserved. And the user operation way is the same as Disco X2 and XBLE. Thus, users can choose the two ways to make a calibration. One is to, after maybe making 8 group or 14 groups of cali shots, users can press the upgrade to let new device a new set of coefficients. Or users can also choose to download all the cali shots to an application in a smartphone and calculate the coefficient in a smartphone and upload the coefficient back to the device. The two ways are also supported. Another function is smart calibration assistance. The device can detect wrong or inaccurate shots in a 4-shot group. If there's a wrong shots or inaccurate shots, the group will automatically reset so that the user to do the calibration to do the group again. And it also allows users to do a duplicate shots or resize the shots in a group at any time. And users can also choose to compute calibration at any time after 8 groups of calibration shots, and a maximum 20 groups are allowed for calibration. For example, the users can make calibration computing after 8 groups of shots, and after make computing, users can choose orderly to make the 9s, 10s, 11s groups of shots. They can make computing at any time, and more ideas are welcome. And another function is magnetic field interference and for calibration detections. The way is to comparing some physics parameters of the two-cycle sensor. For example, the magnitude, the DIP angle, and compensated MX, MY, MZ, and GX, GY, PZ vectors of the two-cycle sensors, and the azimuth and inclination angles computed from the two-cycle sensors are also compared to make sure the shot is accurate. And 3 hole can be sighted on the menu. I guess I just make an experiment yesterday, and the experiment proves that the new device is a more robust anti-calibration laws or magnetization. The experiment is not so strict, but it has revealed some this conclusion. I did the following steps. First, calibrated distal XBLE and Cavway with a very good result. The average error less than 0.2, and distribution is bigger than 98%. And I put a very strong magnet near the two device. I stick the small magnet to each side of the device for at least 5 seconds at the same time for these two devices. And then I make spray shots in every directions. And I make a very simple statistic of the DIP angle and also the magnitude of the magnetic vectors. And this device turns out to be a bigger error, and Canway has smaller errors on the DIP angle distribution. It should be some table and chart showing some data here, but I just did the experiment now yesterday, so no time for me to make some statistic here. And I also make several groups of forward and backside shots in 4 certain directions, and Cavway X1 turns out to be less errors. This is the result that the components layout in Cavway X1 is optimized for magnetic measurements. So I hope the new device will have a better calibration check time. Users do not calibrate it as correctly as this X2. Yeah, that's all my presentation. Thank you for watching my presentation. Thank you for anybody. Thank you for Balkan Cavers Camp to let me give a presentation here today. Thank you.